Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. So we have 6 to the power of x is equal to 9. Now what I'm first going to do is I'm going to take the log of both sides. So we have log of 6 to the power of x is equal to log 9. Now, if we have a logarithm in the form log a to the power of b, an important property of logarithms, also known as the power property, states that we can actually move this exponent to the front of the logarithm. So this would be equal to b times log a. So now I'm going to do the same exact thing to log 6 to the power of x. Now we can think of 6 as a and x as b. So I'm going to rewrite this by moving the x to the front of the logarithm. So now this would equal x times log 6 is equal to log 9. Now, to isolate x, I'm going to divide both sides by log 6 so that we can move log 6 to the other side. So now we have x times log 6 divided by log 6 is equal to log 9 divided by log 6. Now, for our left-hand side, these two cancel out, and we simply have x is equal to log 9 divided by log 6. However, if we have a logarithm in the form log a over log b, this is also equal to log base b of a. So we can think of 9 as a and 6 as b, meaning x would equal log base 6 of 9. So this is our answer. Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this problem. So we have x times the square root of x plus 1 is equal to 0. Now what I'm first going to do is I'm going to subtract 1 on both sides to move this 1 to the right hand side. So now we get x times the square root of x is equal to -1. Now I'm going to go ahead and square both sides. Now, x times the square root of x squared, well, x squared is simply just x squared. So we have x squared times the square root of x squared is simply just x. This is equal to -1 squared is 1. Now, x squared times x is x to the power of 3. And now I'm going to go ahead and move this 1 back. So now we have x to the power of 3 minus 1 is equal to 0. And I moved that 1 just so it could be more simple to square both sides. So now, if we have something in the form a to the power of 3 minus b to the power of 3, this is actually equal to a minus b times a squared plus AB plus B squared. So 1 is the same thing as 1 to the power of 3. So if we plug in our values here, we get x minus 1 times x squared plus x times 1 is simply just x plus 1 squared, which is simply 1. And now this is still equal to 0. Now this gives us two equations. We have x minus 1 is equal to 0, and x squared plus x plus 1 is equal to 0. For x minus 1 equals 0, this means that x is equal to 1. However, if we plug in x, for 1, we get 1 times the square root of 1, which is simply 1, plus 1 is equal to 0. Well, 1 plus 1 is 2, so 2 is not equal to 0. So this is actually rejected. This does not work. So now let's go ahead and try our second equation. Well, to solve this, we actually need to go ahead and plug this into the quadratic formula. So by doing that, we get, I'm not going to waste your time by plugging it in all, we simply get -1 plus or minus the square root of -3 over 2. Well, the square root of -3, this can be written as, I'm going to write it up here, the square root of -3 is equal to I times the square root of 3, because I is the square root of -1. So now this would give us two equations. We get x is equal to -1 plus I to the power I times the square root of 3 over 2, and we also get x is equal to -1 minus I times the square root of 3 over 2. However, if you do end up plugging these into this equation, it actually is again rejected. Both of these are rejected as well. And this equation actually has no solution. So no solution is our answer.